All right. Oh, hell yeah. We got physics, and we're doing uncertainty, problems with uncertainty. Here it is. Let's do a full read-through. We have a swimming pool. It's got a length of 17, a width of 10. And we got a sidewalk. We're going to put all the way around it, and it's going to be made out of concrete. We want to know the volume of concrete needed in the sidewalk. And then we need to find the uncertainty of that volume. You know what I mean? Plus or minus how many meters cubed. You know what I mean? Blah, blah, blah. So anyway, and all these measurements have an uncertainty. So let's just get to it. And here's our lengths, and here's the uncertainty they give us. You know what I mean? 17 meters, plus or, you know what I mean? If we measure a length of 17 meters, it's going to be off by 10 centimeters. I thought that was, that seemed crazy. But anyway, if we measured 1 meter, it's going to be off by 1 centimeter. I guess that's fairly decent. You measure 3 feet. Hell, you're just doing concrete work. Plus or minus 1 centimeter ain't no thing but a chicken wing. But that uncertainty adds up in concrete work. You know, 1 centimeter every. So yeah. So this is 1 meter, and this is 17, and this is 10. And so how to solve this problem is you have to recognize that you have 4 of these squares that are 1 by 1. You have 2 of these that are 1 times 10. And then you have 2 of these that are 17 by 1. So now let's just do that and see how far we get. So but the first thing that I would do, it can be useful. You either do this on the fly or do it up front. Is convert. These are actual uncertainties. Is you convert these to percent uncertainties. So we can do that just right here. So this one is 17 plus or minus. We're going to go 0.1. Divided by 17. That's it. 0.1 divided by 17. We're going to store that as alpha A. That gives us 0.00588, let's just say. And maybe this is too crazy of a number. So if you don't like this number, multiply by 100%. And now it makes more sense. This is 0.588%. And maybe that's better for you. We're going to stick with fractional uncertainty because it can make this problem faster. I'm going to underline it, though, if I use fractional uncertainty. And I'm not going to use labels. Both these are meters because they're actual lengths. Here, this is meters, but this is a fraction. And I don't like to use labels, so this will be just a fast way to do it. This is going to be 10 plus or minus 0.1 divided by 10. What is that, just 1? No. 0.1 divided by 10. Decimal place goes the other direction. This way. 0.01. So this is 0.01. This is going to be 1 divided by 0.01. Never mind. I'm sorry. It's this number divided. It's the fraction that you're off divided by the total length. So 0.01 divided by 1. Is just 0.01. So this one's going to be 1 plus or minus 0.01. Cool. Thickness was in centimeters, but we had to bring the decimal place over twice to get in meters. And now we're going to be right here. It's going to be 0.09 plus or minus. And this is going to be 0.001 divided by 0.09. We got to store that as B. So 0.011. Okay, so now we can go to it. We have 4 of these, so we're going to go 4 times, these are 1 by 1. This is the width here. So this is the small w. This is big W, this is big L. Okay, so, and this is going to be 1 plus or minus 0.01. And we're either going to square it. You can either square it and do that, be happy with that, or do this. You know what I mean? And we'll see which one's more favorable. So we have 4 of those. We added them up. Now we just have 2 of these. And so we're going to say those are 10 by 1s. So we'll do the 10 first. 0.01. And then, yeah, these are fractional uncertainties. So we're going to underline them as such. And we got to multiply the 10 by the 1. And I'm just like to use these values. There you go. Okay, and then we got 2 of the 17s. So we got 17 plus or minus 0.01. Oh, no. This uncertainty was 0.00588. That's crazy. Okay, and then we got to multiply that by the 1. 1 plus or minus 0.01. Okay, we're done. That gives us the area. You know what I mean? That's the total area. But then this whole thing, they want volume. Volume is area times thickness. And the thickness is 0.09 plus or minus 0.011. Okay, booyah. So we got all our fractional uncertainties. This is stored as A. This is going to be stored as B in our calculator. Now, one of the rules is that if you just have a number out here, let's say, well, we got to do this one first. So this says 1. You're going to multiply these together. Anytime you're multiplying together, you have to get either a fractional uncertainty or a percent uncertainty. So this is 1% uncertainty here. This is 1% uncertainty here. You can do the multiplication like normal. So 1 times 1, that's going to be 1. But then your fractional uncertainty is you have to either add the fractional uncertainties together or the percent uncertainties. So this is going to be 2% or 0.02. So booyah. So we got our first one. So now we got 4 times 1 uncertainty is 0.02. There you go. All right, now let's just rock and roll. This is 10 times 1, that's 10, plus or minus, and we're just going to add them together, 0.02. All right, now we can just rock and roll, you know what I mean? We're just doing it 17 times 1, 17 plus or minus, and now 0.01 times this, we add it together. So see how this doesn't, so it's going to be, this is just real easy, 0.01588, if you see that, because it's 0.00. Anyway, so it's going to be alpha A plus 0.01. And there you go. We're going to store that as alpha C. Okay, but that's the fractional uncertainty. I'm going to underline my fractional uncertainties, and done with that. And then we still have to multiply this whole thing by 0.09 once we get there. Okay, now we just multiply it by a number. What the hell does that mean? Well, it means that if you converted it to percent uncertainty or fractional uncertainty, this number does not change. So converting it to fractional uncertainty is going to be king. It's going to be a lot better. Until you actually have to add, and we'll get there in the next step. Because if you take this to percent uncertainty, you just have to do 2 steps to get it back to absolute uncertainty. And what is the absolute uncertainty? If this is the fractional uncertainty, the absolute is just 0.02 times 1, which is 0.02 meters squared. So if we're talking about the area of this area should just be 1 meter squared, but it's going to be plus or minus 0.02 meters squared. That's the error of these areas. Okay, and we have 4 of them, so we're going to we have to add the actual uncertainties up. So it'd be 0.02 4 times, and we would get 0.08. But because this is a fractional uncertainty, we can just multiply these two numbers, so we get 4. Plus or minus, and just keep this as a fractional uncertainty. Because now 4 times 0.02 is just that 0.08. So there you go. Hell yeah. And then let's do this one more time. Because this 4 times this measurement of uncertainty is the same thing as saying, hey, it's the same thing as saying, hey, I have 1 of these. And then I'm going to add it to another one. And then I'm going to add it to another one. And then I'm going to add it to another one. DJ Khaled. All right, so and now we'll still get 4. And these are percent uncertainties. So when you add together, so here's the rule. If you add things together that have the same percent uncertainty or fractional uncertainty, if these are all the same, you just keep them the same, do that. If they're not the same, you have to go to absolute uncertainty, which is 0.02 times 1. In this case, it's basically the same, the fractional uncertainty, because this number is 1. But anyway, we'll see that in the next step. But that's just a nice rule. All right, hell yeah. So that's just a nice rule to know. Okay, so let's get back up here. So yeah, we can just multiply these out, and we don't have to change our fractional uncertainties. So we got 4 plus or minus 0.02 plus 20 plus or minus 0.02 plus, what the hell is this? 34 plus or minus 0.01588, and that's stored as alpha C. You know what I mean? So yeah, those like that. And then this whole thing multiplied by 0.09 plus or minus 0.011. Okay, so now we run into our issue. We can add these two together because they're the same fractional uncertainties. I'm going to underline the fractional uncertainty, but we can't add these two together. So yeah, let's do that. So we got 24 plus or minus 0.02 for our fractional uncertainty. And we need to add it to that number right there. We can't add these together because the fractional uncertainty is different. So you actually have to add the absolute. Like we said, this was 0.02 times 24. So stored as alpha D. That's going to be 0.48. And this is going to be 34 times alpha C. Oh, that's nice. And this is just 0.54. Okay, so this is the actual, and this is meters squared. Because we haven't multiplied by our thickness yet. So this is meters. Okay, so now we have 24 plus or minus the actual, which is 0.48. And we're going to add that to 34 plus or minus 0.54. And that now we'll get 24 plus 34. Now we'll get 58 plus or minus, and we just have to add the absolute uncertainties. 0.48 plus 0.54, which is 0.102. Okay, booyah. We did it. We got our last number, and now we just got to multiply by the thickness. This is stored as alpha C. Oh, but this is actual. This is the actual number. So we actually need to get back. We're multiplying together. And then, so this is the actual number. This is meters squared. So we need to get the fraction. To get that, you're going to go 1.02 divided by 58. So divided by 58. And we're going to store that as alpha E. So hell yeah, you're going to get 58 plus or minus 0.0175. You know what I mean? Good enough. 6. And then we're going to multiply that by 0.09 plus or minus 0.011. This is stored as alpha C. This is stored as alpha E. Alright, so now we just multiply 58 times 0.09. We get the answer in the back of the book, 5.22 meters cubed of concrete. And then we're just going to add the errors, which is alpha E plus alpha C, which is 0.011 plus 0.017, and this is 0.028. Oh no, I got a different number. Let's see. Alpha E. Alpha C. Oh no, this alpha C is totally wrong. No. Where did I store that? Alpha B. Alpha B. Alpha B plus alpha E. Just got messed up there. Yeah, 2.87. So this is 0.0287. There's only one significant figure. Since this only has one significant figure, these have two. This has one. This has one. This has two. So you're on your error. So this has to go to 0.03. Move decimal place 2 places is going to be 3%. And this only has two significant figures because that only has 2, but everything else has 3 except that one. So you got 5.2 meters cubed plus or minus 3%. Okay, booyah. And if you wanted to find the actual, you take this 3%, divide by 100, so that's 0.03, and multiply by 5.2. 5.2 times 0.03, and you get 0.15, you know, basically like 1516 meters cubed of concrete, plus or minus. So there you go. We found the concrete needed for that. And hell yeah, we did it in about 15 minutes. So that was pretty good. That was a good challenge because I just did this problem and made huge mistakes, and it probably took me a half hour. So I just redid it. This is a good one though. Just went kind of fast through it, so it's probably confusing. But thanks for joining me, and that's a video.